Somewhere beyond the sea, somewhere waiting for me, my lover stands on golden sands and watches the ships that go sailing. Somewhere beyond the sea, she's there watching for me. If I could fly like birds on high.
Ow. What is this? Wait a minute. I've seen this somewhere. Oh yes, the same thing happened to Newton when he first discovered about gravity. Still, some people believe that this story is nothing but a legend. However, people have started dwelling on these kind of questions way before Newton, and it goes all the way back to the ancient Greece. So I think it's important to start with around 4 centuries before current era, the famous philosopher Aristotle has laid the foundations to physics. And he based his conclusions not with equations, but due to the observations. His ideas were purposeful and earth-centered. You see, back then, the dominant theory was geocentrism, which means that the center of the universe was our planet Earth, and every planet was circling around it. And the Earth itself was composed of 4 key elements: earth, water, air, and fire, each seeking its natural place. For example, rocks fell out of the sky on the earth because it has yearned for the earth, and the flames rose high because it has reached for the heavens. The heavens, in his understanding, were perfect and unchanging, made of a 5th element called ether. Aristotle's model of the universe were elegant, but however completely wrong. But it still did hold up to 2,000 years because it matched what people saw: perfect earth and stable earth under the predictable stars.
But before Aristotle, Plato had proposed a radically different view. The physical world was an imperfect reflection of pure mathematical forms. To Plato, true reality lay in geometry, perfect circles and unchanging numbers, while the world we saw was mere illusion. But Aristotle rejected this. For him, truth came from observing nature, not abstract math. This clash, empiricism versus idealism, would echo for centuries. Aristotle's ideas were preserved and refined by Islamic and Christian scholars. For example, Ibn al-Haytham, in 11th century, he conducted optics experiments, proving light traveled in straight lines and vision required reflection, not, as Aristotle thought, rays emitted from the eye. Meanwhile, in medieval Europe, Thomas Aquinas fused Aristotle's physics with Christian theology, arguing that the unmoved mover was God, the ultimate cause of all motion.
But the ancient physicists were far from finding all the answers to their questions, and only further progress would unravel the things that were unknown. Which brings us to the 16th century dawned upon Europe simmering with unrest, rebelling against the church, rebelling against the original scientific dogma, and rebelling against Aristotle's ideas about the cosmos. And then comes the Nicolaus Copernicus, who on his deathbed in 5043 drops a bombshell: the Earth moves.
He proposed a heliocentric model of our universe, meaning that all the planets were actually circling the Sun. And it wasn't just a new arrangement of planets, it was a philosophical declaration. If Earth wasn't central, then humanity wasn't the universe's focal point. Another one of important discoveries was in Venice, 1609. Galileo Galilei, a professor with a knack for trouble, heard of a Dutch invention, the telescope, and built his own. When he pointed it at Jupiter, he saw 4 moons orbiting another world, defying Aristotle's claim that all celestial bodies circled Earth.
This period in the history of philosophy and physics has also seen one of the most greatest inventions of all the humanity. Cambridge, 1687. Isaac Newton, a precursive genius, has created Philosophiae Naturalis Principia Mathematica and gave the universe its operating manual.
He suggested 3 main laws of motion. First one, an object stays still or moves uniformly unless pushed. The second one, force equal mass times acceleration. The third one, every action has an equal and opposite reaction. And of course, his famous law of universal gravitation, with a famous story of an apple hitting his head. Furthermore, Newton saw space and time as absolute and fixed, but this would haunt physics for centuries. As Newton's laws spread, philosophers clashed over how we know nature. Some scientists, like John Locke, argued knowledge comes only from sensory experience, while others, like Gottfried Leibniz, insisted that some truths are innate to reason, like math.
But there was one problem. One could only go so far on theory alone, and that brings us to the 19th century has dawned upon an industrialized world, railroads, factories, and the hum of steam engines. Physics was no longer about just planets and falling apples. It was about explaining heat, light, and invisible forces.
Paris, 1824. A young military engineer named Sadiq Carnot asked a revolutionary question: what makes steam engines work? And his answer birthed thermodynamics and revealed nature's cruelest law. The first law says that energy can't be created or destroyed, only transformed. And the second one, in every process, useful energy is lost forever. The universe is sliding toward heat death, a state where no work can be done. And the dream of infinite energy was unfortunately dead. A little further in time, in 1830s, in London, Michael Faraday, a bookbinder turned scientist, saw what Newton missed. Forces weren't magic, they were fields. And later on, in 1865, the Scottish genius Maxwell united electricity, magnetism, and light into electromagnetic waves, revealing that light itself was a ripple in this invisible field.
By 1900s, classical physics seemed complete until Max Planck introduced quantum theory and Einstein shattered Newton's absolute space and time. And that brings us very close to one of the most interesting and practical stages of physics, and I'm very excited to tell you about At the dawn of the 20th century, physicists were sure that they had nature all figured out. That was until Max Planck had made a desperate guess in 1900s. You see, he wanted to find out why hot objects glow, and he proposed that heat and energy was stored in tiny packets called quanta.
To be completely frank, even Planck himself didn't believe his own idea. It was an act of despair, he confessed. Another thing that shook the world was Albert Einstein's theory of relativity. While Newton said that space and time were absolute, Albert Einstein said,
time and space are actually relative, and all of motion must be relative to a certain frame of reference.
And that in its turn has created a huge scientific paradigm shift, and the quantum genie was already out of the bottle. Meanwhile, great discoveries were being made in the Copenhagen School of Quantum Physics. However, there were some contradictory theories in the school as well. You see, Albert Einstein believed in determinism, a theory where every event had a precise cause. In his understanding, everything had its purpose, saying God does not play dice. Whereas Werner Heisenberg argued with his uncertainty principle. He stated that the quantum world was so small that it was impossible to predict the position and the momentum of a particle with precision. So that is why Einstein's world was deterministic, while Heisenberg's world was probabilistic.
December 1941, US enters World War II, and it has built a separate city called Los Alamos, where physicists from all over the world has gathered and tried to harness the potential of quantum physics and create an atomic bomb.
J. Robert Oppenheimer, the brilliant and tortured physicist who led the project with other remarkable scientists. He spoke Sanskrit and quoted the Bhagavad Gita, yet oversaw the creation of the most destructive weapon in the history of humanity. In July 16, 1945, the first atomic explosion was tested with the code name the Trinity Test. As the fireball lit the desert, Oppenheimer whispered,
"Now I am become death, the destroyer of worlds."
And after that, in August 1945, 2 bombs were dropped at Hiroshima and Nagasaki, with 200,000 dead. Physics had changed the warfare forever. The 20th century has taught us that knowledge is power, and power corrupts. Physics gave us nuclear energy, and consequently nuclear war. The only question remains, can we handle what we discover? So it's been quite a long journey. We've come from myth to math, from ancient physics to modern ones. You see, human beings has always been curious about the unknown, but the history shows us that once we unravel it, it can become a potential danger to the humanity itself. So the question arises, if we advance any further, wouldn't it be better to use these inventions to create life? Rather than destroying it?